Today I'm going to be talking about how to make dynamic split screen in GameMaker Studio 2, like this. When I say dynamic split screen, what I mean is when you've got two players and they're close together, you just have a single screen, but as soon as they go far apart, then the screen splits so that they can see what's around them better. Bear in mind, everything in this tutorial should also apply to GameMaker Studio 2.3, which I'm sure might be a question some people will have since that is coming very, very soon as of the time I'm making this video. There might be some background noise during this video because it's the middle of summer and the cicadas are screeching and I've got a fan on, because otherwise I'd cook to death while trying to record this. So please keep that in mind. Okay, cool. So the first thing we're going to do is set up cameras and views, so we'll need an object to manage that. I'm going to call it Object Camera Manager, and then add the create event. Yeah, I'm also going to give it a sprite so that I can tell where it is in the room editor, make it invisible so it doesn't draw the sprite, although I actually disabled exporting the sprite so it wouldn't draw it anyway, it would just make an error message, which still wouldn't be nice. So I'm going to go to the room editor and I'm just going to pop it in. And that's that. So now we need to set up the views and the cameras. So first we need to enable views. And then we need to make some views visible. We need view 0 to be visible since that'll be the combined view and we'll default to have that one open. And then we want views 1 and 2 just to make sure that they're invisible because they will act as the split screen and I want rooms to start with the combined view and not the split view. Okay, well we need to set up the viewports as well, so we need to use a width and height to base it on. And I'm going to just use the window width and height just as a baseline, so you can change the boot room size and it will just be reflected in the views in the following room. So full height is equal to window get height, and full width is equal to window get width. I also want to define the border size, as in the padding between the two split screen views when they're combined, because sometimes if there's no border between them it can be really hard to distinguish where one view starts and the other one ends, so I like to put a bit of a border in. And I'm going to make that border size 2. I'm going to put it in a little var so that it's easy to change if you want a different one. Okay, now let's set stuff up. For the default view, for view 0, the combined view, we just want it to occupy the full screen, so we'll just set that up normally. I'm going to set the export and Y port to 0 as well, just because I want to be sure they're in the right place, even though by default they should be in the right place anyway. It's just a safety thing. So, width port and height port need to be the full width and the full height. Okay, and then we can set up, I'm actually going to just slap a comment in. And then we want to set up the width ports and H ports, and just the ports for the other two views. They're virtually the same, only the second view will be put lower down at the bottom of the screen. So let's do that. Use the full width, and then the height I'm going to do them stacked top to bottom, so we use the full height minus the border size and then divide it by 2, but it's faster to multiply by 1/2, and then that's the height done. And then we repeat that again, change it for view 2. And then the difference is we want that height, the Y position of this second view to be lower down, which is basically this, but instead of removing the border size, we add it, and that puts it on the bottom half of the screen. And then to test this, we can just, it will use the combined view, which ain't great, but you know, it's a start. Okay, there you go. It looks very big right now because I've not actually set up the cameras. So now we want to set up the cameras. So I'm going to create the first camera. That will be camera combined. And we will use camera create view because it's easier. And we'll just put it in 0, 0, use the full width and the full height. We will then assign that camera to view 0, and that will fix the size. There you go. Currently it doesn't follow anyone, but we'll sort that out later. And then we want to set up the split views, the individual views. So that's basically, we can take this again. But we want camera, I'm going to go camera P1 and P2 because then it's easy to remember that one target's player 1, one target's player 2. Now the difference is their height needs to be different, and we can reuse this algorithm here to do that, which we could just either store in a var, or we could use view get h port. It's however you feel, really. So actually I will put that in a var, and I will go var split view height equal to that. And that will just save it some math. Oops, I accidentally did that. And then we view set camera that as well. And we'll do that for both of those. Oops, why did I copy that? Yeah, we just want this. And then I can just copy and paste that. And set it up for player 2. And then just as a test of this, what I will do is I will make these false. So make view 0 invisible and views 1 and 2 visible. And we should see that they're all in the wrong place and the two views will look like they're in the same location. But we will have a black line between them, which we do. So that's worked well, that's good. Okay, cool, so that's the cameras and the view setup. We just need to actually make them follow something now, which is... There's a little more to that, but we'll just make view 0 visible again first. And what we'll do is we'll focus on the combined view follower first. So we will want to create a script for that. And I will call it camera script both players. This will be the script that is used when both players are using the same camera. Because we've created the script, we might as well assign the script to this. So we'll go camera set, I believe it's update script. Yes. And we'll use that for camera combined and camera script both players. And I will assign that. It will not do anything yet, but we have it set up. And then because we are updating properties with the camera in this script, we will want to make sure we can get the camera in that script. And there's not actually a nice built-in function to it, but assuming you're using views at the time, if you use view camera view current, that will represent the camera currently calling the script, which is useful. So this cam equals that, and we will need that because we will need to change some properties with the camera in order to move it correctly, with like camera set, view, pause, etc. But what we need to do with this script is we need to get the bounding area of any visible players and then center the camera around that point. The way I do this is first I get the player count in the room, which is player count, which I just call pcount for short, instance number of object player, which is great. And then if there's more than 0 players, then we know that there needs to be some math done. And we can actually check the camera later because we don't need to get the camera. If there's not enough players to actually change any properties in the camera, we don't need to change any properties because we're not following anyone. We then set up some default variables, which I'm actually going to use var p1 is equal to instance find object player 0, because we want to set up some minimum and maximum bounds of the players. And instead of iterating through them all and setting up some default things, we can set our var min x equals to player1.x, and then we can duplicate that. We can have our max x is the same, our min y is the first player's y position, and our max y is the same as our first player's y position too. Okay, and then we will use a for loop to iterate through the other players and update this to represent the actual bounding box. So we will start at I equals 1 because we've already checked player 0, so we don't need to check anymore. If I is smaller than player count, well, while I is smaller than player count, then we will keep iterating, and then we plus I. And then we want to find the current player, which I will call Pn, which is player n, essentially. but a short variable name so I don't have to type lots of words for no good reason. This will also mean that the loop doesn't actually get called at all if there is only one player, and then it will just base the camera on the central bounds of one player. So that's nice. Okay, so min x equals the minimum of min x, or player ends x. And then the same for y. Oops. And then the same again, but for the maximum values. Okay, and now min x, min y, and max x and max y now represent the bounding box. We have our current camera, and so now we just want to center it about the camera, which means we want to set the camera position minus half of its width and height, so that it's centered between the two players. So we will do this. I'm going to use a local variable, new x and new y, which basically just means I can store them in a more readable fashion. This will be equal to minimum x plus maximum x minus the width of the camera, this cam, divided by 2 or multiplied by 0.5, which is just a simplified version of saying the middle point between min x and max x minus half the width of this cam. This is just simplified math. It's already broken down. And then we do the same again for y. Only we use height instead of width. Okay, and then we just camera, set, view, pause, this cam, to new x and new y. And now when we run the game, we should find that the camera tries to stay centered between the two players. And there you go. Now you'll notice that like the top player, the higher up player, looks a little bit like close to the border because their origin is where their feet are. So it makes them look a little bit close, so I like to add a nice little bit of offset. So we get to have this. So I get to go var vertical offset, and I found for this project about minus 35 was good, and then I can just add that to the new y position, and then it should, once this is done, this makes the two players stay more visually within the view rather than just based on their true position, which is good. I like it. Okay, so that does that. We've got views and camera set up, and we've got the main camera centering itself between the two players. Now we need to set up the split view cameras so that they follow the players individually. And then once all the cameras are set up, we can focus on making the camera modes change depending on the distance between the two players. Let's get into setting up the views for the individual players when they're separated, the split screen cameras. So we'll need another camera script to start with. And I will call it camera script. Just individual players, I guess, since that's what it describes. And this one, I think we'll go easy with to begin with. And we'll just make it follow a target and center the target in the view, just to keep things simple, just for testing. We'll actually need to be able to decide on... I want to use the same script for two cameras, so we'll need a way to actually find the object the camera is following, but we'll set that up in a bit. First things first, we'll just make the primary view, the combined view, invisible, and the two split screen views visible so we can test them. So as you can see, when I run this, you can see we've got the two split screen views, but they're not actually doing anything right now. So okay, in order to make the cameras follow the individual players, but also use the same script, we need a way to actually assign a camera to a player or a player to a camera. And while you could use camera create view and set the object in the extra arguments, there's not actually a way to get and set that later, which will be useful later on. So that's not really practical. And also, if the object is created after the camera is, which in this case it probably is, then it can't be bound to it, which isn't super great. So we will need a global variable ideally to do it. And what we'll do is we will copy the way the view object worked in early versions of GameMaker. We'll just make a global variable, and we'll call it view targets. You could call it view object or whatever if you wanted, and I'll just make it into an array that is 8 indexes big, because that's how many views you're allowed. Or I actually want to clear it to no one, so that it doesn't think that it should refer to self or the 0th instance or whatever, or the top object in the list. Because if it's 0, then it will probably just refer to the object player generally rather than no one, which won't be useful for a test we'll do later. And then we actually just want to assign the object players to this camera list, this view target list. So we will do that in room start of the player object. That's in other. We're doing it in room start just to make sure that view targets is an established variable before we start trying to assign to it. And then because of how I've set it up, I just want to assign that to player index. But I want to add one because view 0 is reserved for the combined view. And we'll just set it to the ID of this object. So that's that. So now we have a way to reference the view players based on the view in a global variable, which is neat. So now, back in the original script, we can now say that the target is equal to an index in here, and we can just use view current. And hey presto, we've got it. So we just want to check that the target actually exists, so that we don't start trying to read variables that aren't there. And then we can move and center the view based on it. So we will know that our camera is the view camera for the current view, as we did in the combined view script. We want the same vertical offset as before, so that the characters still appear in the center-ish place properly. So they're properly visually bounded by the view. And then, same as before, we want to have a new X and a new Y. And then we would set to those values, and now we will just define what those values are, which is just the target X and the target Y. In this case, plus vertical offset because it's Y. And then we just want to add or subtract half of the width and height of the view. To center it properly. And that's actually the basic script done, probably. So now all we have to do is actually assign that camera script to these. And that's done again with camera set update script. And then because of how I set this up, they can just use the same script. Being careful not to leave the parentheses on the ends of the script so that it doesn't assign it to the result of the script, which would be undefined. So that, assuming we've done that correctly, oop, I left that's P2, that wouldn't be good. Assuming we've done everything correctly, we should now have the two views following both players separately, but completely fixed in place. Okay, so player 1 is centered properly, and player 2 is centered properly. Okay, cool. Now we can move on to making the views split and combine based on distance. To begin with, we'll do an instant transition, so it'll instantly split between split screen and single screen. So it'll be a bit jarring to begin with, but it gets the concept across, and then we'll work on some smoother animations later, which will be good TM. In order to split and combine the views, we need to check the bounds again and see if the players are a certain box apart before it combines together. And we can do this with the same code here. We could, in theory, flag whether or not we need to combine and split the views in this script, but later on when this script is inactive, when camera 0 is invisible, or the camera for view 0 is invisible, this script won't be executed, so the bounding box calculation won't happen. We will instead do the bounding box calculation in the end step of the camera control object, which will make sure that it calculates the bounds based on where the players are after a step has finished. So it'll have all their speeds added to their positions and stuff. So add a nice end step event. Now what we could do as well, which would be quite useful, is do this calculation for the bounds, which we can just copy most of this code and remove the camera related stuff. And there we go, I've got the bounding box sorted. We could store this camera bounding box in a global variable and put it in here, reference it in here instead, and then it wouldn't be an issue anymore. We could do the math once per step and then just deal with it in the camera. So I think we'll do that. I think we'll add a global variable. So we'll start with something simple. We'll go global.playerBounds equals array create. It only needs 4 entries and they can default to 0. And then we will this camera script should run after the first step has occurred, so I don't think we have to worry about whether or not it'll be in the wrong place to begin with. So yeah, we're just going to use this, and we're going to set 0 to min x, and then do the cheeky duplicate. 1 will be Y. So it works in standard rectangle order. And then 2 and 3 will be the max versions. And now I can move that code, move this global player bounds thing into here. I might as well make sure player count's above 0, but there's not really much point. We can just set the bounds based on this. So it's the same thing again, but we just want to grab the local variables from the global one instead, because it'll be slightly faster than doing the math twice. And there we go. And then we don't have to worry about doing any math unless there are actually any players. So we'll leave the p count thing there. Yeah, actually, just to test this, we'll make the bounding box view the main one again, the combined view the main one, and give it a run, and it should run exactly the same, but now we have the bounds calculated in one place instead of potentially doing it in two, and there we go. It split correctly. And now, based on these player bounds, we can do some math, and we can split and combine these views. So we can leave this as is, and we can do some bounds. So what I want is I want a border size. I want a border to determine how far away from the edges of the screen the players have to be that'll cause the split to occur. And then it'll go between them, or it'll combine them when they're within that sort of bounding box. We'll use a border size of 228 because that's what I liked apparently. Okay, in actual fact, I used an effective border size of 114, and that was a comfortable size. So basically what we want to do is we want to check if the bounding box width or the height of the bounding box is smaller than the camera view width or height minus the border size, but not just the border size times 2, so that it's like shrunk smaller in both sides. So we will do that. That's fairly straightforward. All we have to do is check that the maximum x minus the minimum x, which will always be a positive number, is larger than the width of the combined view camera's view. That should be view width, and we want it to be the camera combined, or did I call it combined camera? Okay, I called it camera combined. So we've got the width, great, and then it just needs to take off 2 of the border size. And this isn't the only case where the view should split, because basically we're saying if the bounds, the distance between the two players on the x-axis is bigger than the view width minus some border size, then it'll split. But we also need to do that for the y. So we will add a sneaky OR, and then we can actually just copy and paste this bit, change that for y, and change that for height. Obviously, if you've got the border size too big, then it'll just be stuck in split view. So you don't really want to do that. Okay, so now we've got a case where the two separate views should be visible, and then the else case is where the combined view should be visible. And just to make sure we don't change any weird stuff when we don't need to, all we need to do is just need to check if view visible 0, just check if the first view, the combined view, is visible, and if it is, then we want to make it not visible. And we want to make the two split views, the split screen views, visible instead. And then on the contrary, in the case where they're separated apart, we want to check that the view 0 isn't visible, and if it isn't, then make it visible, and make the other two not visible. And now, when we run it, it should, hopefully, if I've done everything correctly, now split and merge the views when they're close apart or far away. So we start and they're together, and then I move them far apart, and they split. Now, the only trouble with this is, obviously, it's an instant split, and it's a bit jarring, and one player is always on top, one player is always on the bottom. There's no animation, so it's a bit like, woof. And you might also notice that just in the middle here, there's no black border anymore. There is a smear, a remaining image of where the combined view was, which isn't really desirable. There's two ways to fix this. You can either, in the pre-draw event, target the application surface and clear it to whatever color you want, or you can do the nice and easy way, which I don't think can be done through code at all, but if you go to the room, and you go to the room where the camera's actually in, and you go to the viewports and camera settings, if you enabled clearing the viewport background, which I don't think can be done through code currently, which is interesting, then if you go back to it, now when it splits, you see we get the black border again. I'm not actually sure where it gets this black colour from, you know. I'm going to check. Because there's no background here, and the colour's white, and there's no way to set a colour in the room settings. I wonder how you can actually change that. It might just be stuck black, unless you use the pre-draw event. So if you want a different coloured border, if you want to, you know what, I'm gonna show you how it works. If you want a different coloured border, you can put this in any object that actually draws stuff. So I'm going to put it in sorted rendering because that object actually draws stuff, and then I don't have to do any special test cases for the camera. So if you go to pre-draw, you could just write draw clear. I'm going to use red because it's really obvious colour, and disable that so that we don't notice it. Oh no, hang on, that's clear display buffer. Wrong thing. Now we'll see nothing happens. Change the wrong setting, but yeah. The pre-draw doesn't actually do anything unless you actually tell it to target something. So I'm not sure if it actually draws to anything without this, or if it's just because I'm drawing this, but then because the application surface is enabled, nothing's happening. I might find if you disable the application surface. So if I disable the application surface, does that make a difference because I'm drawing to the window buffer instead of the application surface? Yes, it does. Okay. If the application surface is enabled, this will do nothing. If the application surface is disabled, it will clear the border to the right color. However, in most cases you'll have the application surface enabled because it can be quite useful, though it can be quite slow in some mobile games, so, you know, your mileage may vary. But if the application surface is enabled, you do want to check if it exists. And then if it does, you want to target it. You also want to know how to spell it. That's very important. And now, because the application surface is enabled and that's disabled, we can now actually clear the border color. You could actually just fill with a rectangle where that zone is, or use the GUI event, the GUI event, if you want to draw that line for potentially cheaper. But this is a nice easy way of doing it, just having a default color. But yeah, now you can see we can make it red, but because I don't actually want to make it red, I'm just going to comment that out, and I'm just going to enable that, clearing the viewport background again. So yeah, anyway, that's how you change the border color. Whoop whoop. Okay, so moving on again, we now have a dynamic split screen that splits and combines when you're a certain distance apart, but the animation's ugly, and there's some quality of life stuff that could be changed. So first I think what we'll do is we'll add an animation for when the viewer actually splits in the first place. That one is very easy. It doesn't require any particular fanciness, but it does require some level of fanciness. So what we'll do is, there are two things I can do, but for now we'll focus on the easy one. You may notice I set these variables to be new x and new y, and that is to make this bit a bit easier. It not only makes everything readable, but it makes things easier. And what I'm just going to do is I'm going to use the lazy person's way of animating a view and just use a nice lerp so that it just smoothly moves in a direction. And that works pretty well and looks nicer than no lerp, so we'll use it. Okay, so instead what we'll do, well, now what we'll do is we'll set the new x and new y's to lerp based on the camera's current position. So we'll move from the current position of the camera to the new thing, based on some lerp rate, so you can tweak it to your liking. So I think I like a lerp rate of around 0.2 in this case. And then we duplicate that, we add y, and hey presto, oh, that wants to be a y too. And that will make them smoother, but this will also make something else noticeable in a minute. And that is that the views don't move until the camera is visible, so it will jump from where it was last. So you'll notice the top one isn't moving at all because it's still in the right position. And so that's jarring again, and the bottom one, because it's the one I'm moving, it's in the position it last was in and it teleports over. So we need to fix that in a fantastical, magical way. And what that is in that event where we flip the camera visibility, we need to move those cameras, and we need to move them to where they are relative to the base view, the combined view. So what I do, I believe, is I find the base X, We'll call that cam C X for camera combined X. And we'll get the view X of camera combined. And we'll get the view Y of it too. And then what we want to do is we want to, for the camera for the player 1, the top camera, I know it's called P1, but that'll actually be less relevant later for reasons I will explain. For this one, what we want to do is we want to camera set view pause. In the case of camera E1, that is actually just the same. In the case of P2, however, it needs a little more math because it needs to be based, its position on the screen is different, so it needs to be shifted differently. Its Y position is the same as the base Y, but we also have to add the height of the combined camera. And then because that would put it below the actual viewport of the camera, we then need to take off the height. We then need to take off the height of camera P2. And then this will align it properly. And we'll see in a minute when I run it again. Now there won't be that weird teleporting thing. It'll now actually look like it's separating, it's splitting. So if you look, hopefully... Oh, there we go. And now if they combine again, instant combine still. Oh, there we go. Now, I could move on to the combine animation, but there's one more thing I want to show first, and that's if we go on top, we swap around the position of the players and put the blue one on top and the red one on the bottom, the camera moves like that, and it's kind of also jarring in some cases. This is an optional thing that I would put in optionally, but I find it easier to process where you are if the camera splits based on who's on top, so the person on top stays on top. And here's the cheeky way I do that. We have this. We have view targets. And I know view targets index 1s and 2 are the 2 player targets. And I also know they both exist. So normally I would have to check whether or not they exist. But in this one where they flip round, where we enable the split views, there's a cheeky thing you can do. If you check the Y position of view target 1 and you see that it is larger than the Y position of view target 2, which in this case is player 1 and 2, and we know that view 1 is higher up on the screen than view 2, then what we can actually do is we can copy view target 1 temporarily, then set it to view target 2, and then set view target 2 to what was originally view target 1, and it will flip round which camera follows which player. And this will... Oh, hang on. This needs to be TMP. Yeah, this will flip round which camera follows which player based on where they are on the Y during the split, which will reduce how jarring it is significantly. So if we look, normally if they do the same way before, we have that. Then, if we put the blue one at the top, it splits the other way around. And so the camera zips round a lot less. And in some cases this can be jarring if someone's used to looking at a specific part of the screen for the thing. But I feel like this looks a lot smoother and a lot easier to figure out where you are, because you're already looking at the top half of the screen if you're at the top half of the screen. So if it splits and keeps you on the top half, then you're still in the right place. And same for vice versa. If you're on the bottom half of the screen and you're already looking there, then when it splits, you'll see you're still there. So that's cool. So anyway, I'm just going to slap a sneaky comment on there and say swap or make cameras target the, or pick a target, swap the targets if the top target is further down. Ooh. Oof, I guess. Makes the transition less jarring. So that's cool. Obviously this code doesn't look super readable if you don't like specifically say. So if, for example, view targets 1 and 2 are both the players, hard coding this is kinda bad, but it works for now. So realistically you'd probably want to like have a better way of tracking these targets, also check that they exist, because if one of them doesn't exist, then this will definitely crash. So yeah, it's probably worth going if instance exists for both of these. Just to make sure it doesn't crash. So what does that leave us with? We have the views splitting apart animated. We have them swapping based on Y position. We have them splitting full stop. You can add tweaks to this. Like in the individual script, sometimes what I do is I add a sneak A to the new X and new Y. A length based on the speed of the player and the direction the player is facing. I'm going to do ×2. These are just magic numbers. This is all completely optional, but just something that I like to add so that in the direction the player is facing, they get to see more of the world. So it can make it a bit easier to see what's coming. So, okay, this won't do anything when they're combined, and it never will. But, okay, I did not increase that enough at all. Ah, okay, that's why. Because I'm asking for the camera speed, the target speed and direction. I'm going to leave this in because you might as well see that I make silly mistakes because everybody does. Yeah, there you go. Now it's using the target speed and direction. Now when they're split, you'll see that the camera does not move that much because I'm moving quite slowly. I just realized I'm moving at a speed of 2. And 4 pixels is not very much, especially when you're lerping. So if I move that to like 12, then suddenly you're moving 24 pixels. That is a significant increase. So if you look now, you can see that the camera sort of nudges in the direction the player's walking. You play with these values all you like. I'm going to change it to 32 now. And then I'm going to uncomment it later anyway because it's not really needed. Or I'm not going to uncomment it. I'm going to comment it out later because it's not really needed. Yeah, if you look, now you can see more in the direction you're actually moving in, which is a nice little feature. Not the focus of this, but it might be something you'd be interested in putting in your games. But anyway, I'm taking it out for now because I don't actually need it here. It will still be in the downloadable project though, so that's nice. Oh, I don't want to comment that out. Okay, so what's left? Animating the recombination of the two views. That one is a little bit more tricky because you can't just enable the new view and jam the new stuff in. What you have to do is you have to move the two views to where the original view is and then make them invisible and turn the new one on while they're within the range. So that one is a little bit trickier. Hence why it is the bonus I have saved for last. So the first thing I do to make this a little bit easier is I go back to the camera script for both players and I add a nice optional argument. And what that is the purpose of that is so that we can pass the camera to this script even without the camera having to call the script, so I can actually update its position when it's invisible so that the two other cameras have somewhere to like travel to easier. They know where they should travel to, which is quite useful. So anyway, this cam is now not going to be defined immediately. It still will be defined. It just won't be defined there. It will be in an else. So that when the camera is running the script, it knows to just use the current camera. But the argument, is larger than 0. Then we know that a script is calling this. Because currently, cameras don't actually pass any arguments to the things. It would have been kind of neat if they actually passed themselves as an argument. That could have been useful. But, you know, doesn't matter too much. But now we can say that this cam is equal to argument 0. And this is handy because it means in here, in end step again, before... we're not going to make this visible yet. But now, even while it is invisible, we can update its position properly. Suppose optionally we also want to add a sneaky arg. Mark it as optional. There we go. So yeah, now that will update the position of it. Because we will be animating the movement of the two split cameras towards the position of the combined camera, we need to disable their update script since that's also animating. And the two animations will end up fighting each other. They'll both be trying to back and forth and it'll just not work. So we actually set update script. We actually, for the camera P1 and P2, actually want to disable their update scripts for when the camera updating is combining by setting it to -1. However, when the camera does split again, when it's in split mode, we do still want to make sure they have their original scripts. So I believe you might want to store this in a variable or something, but because this is a very fixed tutorial, you also might want to learn how to spell. Okay, apparently not. Apparently I did know how to spell. Yeah, you just want to set them to have their scripts again when they're split, otherwise nothing will happen. So now what we'll find is if I run this, it'll start with the views combined, then they'll split, and then they'll never combine again. The views will just freeze in position, and then when we get close again, when we get close again, the two views will freeze and stop moving, like so. And then when they move far apart again, they'll gain their animations again. Or they'll just never gain their animations again. Because view 1's not visible. I see. Now, I would put this in with if view is not visible, but then that would mean that if you move close together, but the views haven't merged yet again, and then you move far apart, then they'll not do the thing, they'll not regain their animation back. Which is a tiny edge case, but you know. You could also have a combining state managed, so you could have a views combining state. Actually, I think we will have a views combining state. And then that way we can actually do something else. Then this won't matter. I can leave this here. And I can do this. This is all within P count, so I'm not sure. I don't really want that within P count. I don't really want any of those within P count, actually. I want that there. Oh, am I going to have to reorganize that? I'm probably going to have to reorganize that. I don't actually want any of the view switching stuff to be within the P count thingy, because I just realized that doesn't want to be the case at all. I want these to be defined here. I want min x and max x and all them to be defined here. I want to remove that. Oh, I can't believe I made a silly mistake. Like that. Should just be able to copy that. Paste it in. Bam. Okay, so now that's in the right place. So now I can do the cheeky cheek and say that if we're using the camera combining state, if those cameras are combining, or the views are combining, then we do something. But if they're not combining, then we go back over here. And this will just help us minimize math. So that's doing the thing. Now we want to set that the views are combining. And that will stop all of this code running, which is wonderful. And just to keep things cheeky and cheap, we'll just go views are combining, then we'll set views combining to false. This will be before we actually do the test, and then we want to have the opposite of this occur. So we want view 1 to be, not view 1, view 0 to be visible, and make the other two views not visible. And this should result in the instant switch again. Which, you know, will be boring, but it's there. We just have the views combining state now, which is kind of handy. This will mean that if you sort of like wobble between the edge of the views in a minute, it'll like have to combine the views before it splits the views again. The original method I would have done would have ignore the animation and just resume what they were doing. Although you could still trigger views combining to be false based on this if you wanted. It's an option. Now we do the fun thing. We want to move the split screen views to where they would be. We want to move the split screen views to the positions that they would be in on the combined view. This basically means that the P1 camera will move to the top and the P2 camera will move to the bottom of this display, and then they'll merge. And camera magic. We need to get the view positions again, which we can actually just use based on this camera combined thing. We've already updated the position of where the camera should be, although because the players are moving, we will actually still need to repeatedly do that. We will still need to update that camera forcibly while ever that view is not visible. Oh, and I actually need to move this to a state, but we'll worry about that in a minute. Yeah, I need to do these as well too. I need this for player 1, or the top camera. They're not actually for player 1 or player 2 anymore because of this swapping code we put in. Either way, I need their positions. Okay, cool. And then I need to move them. We will lerp. We will lerp these things. We will just lerp them. We will lerp them straight up. Lerp it from its current position to where the combined position should be by lerp rate. Both P1 and P2 x's are the same, or they go to the same position. And then last but not least, it just needs to lerp the Y positions. The Y position for the first one, the top screen, is just the same as the X one, but with Y subbed in, because it goes to the top of the screen. And then for the second camera, we have to do that teeny bit of math again, where we get the height of the combined camera minus the height of the bottom camera. So that is just the same as going back over here and grabbing this sneaky bit of code. It's just the same position. We're just trying to put it back in that position relative to the main camera. And there we go. So that will now lerp them to where they should be, which is still not what we actually want. Especially if I put that in its thing. I'm just going to put an if false for now so that code never runs, because we're going to be using an if statement anyway. But we'll replace that false in a minute. So now we should find that they start combined, they split apart when we walk apart, and then they animate to where they should be in a combined view and never recombine. Or they just freeze. Ah, see, we didn't consider that. And the reason they just freeze is because you actually have to set the position. Believe it or not. It doesn't just magically do it because you want it to. Okay. And now... why did I leave that as a P1? That's not good. That could have been another bug. Okay. Now, they will do what I described, where they will sort of look like they're going to merge, and then just leave the split in the middle anyway. So let's hope. Ooh. I've made a boo-boo. And I can see where I made that boo-boo. I left that as a 1. My boo-boo is repaired. Now... third time's a charm. We should get that thing where it looks like it's trying to yeah, there we go. It looks like it's trying to recombine. And look, it almost works. But that borders their fooling us. You know, actually, I kind of like that lerp rate on the combined camera, which I didn't think was necessary. Okay, but anyway, when they walk far apart, nothing will happen because views combining never stops. Now we just need the recombine case. And basically what we just want to do is just make sure that the camera positions aren't actually moving that much anymore. We just want to check that they're close to their target positions. And we know what their target positions are. But yeah, I just need this. Varcam P2 target Y. Just to make life easier, we just need to combine this all into one variable. Because I'm going to be reusing it. Pop that in there. And then we'll have the same result. And now all I want to do is the magnitude of something is a squared plus b squared equals c squared. But you want to square root that to find the actual distance. But we can save some time by using the square value of c, which will be the distance, and compare that. So what we can actually do is we can use the square of cam p1 x minus cam c x, and that'll be the distance on the x between the two things, plus the square of the same thing again, but for y. Again, this is just Pythagoras, which would be equal to, in actual Pythag, this would be equal to c squared, because the square root of these is the actual distance from the target point. But square roots are expensive. So what we can actually do is we can just check if it's larger than the square of the target distance, which in this case I'm going to say is 0.8. Probably actually 0.5, because then there should be past the point of rounding errors. And I actually want to check if it's less than that. But we don't want it to just be in the case of the top view reaching its target destination. We want both the views to reach their target destination. So we want to copy that and have an and. and then swap it for 2, and then that one for 2, and then instead of cam CY, we need to undo my bird's work. We need to use the camera to target Y. So now, if both of them... hang on, I didn't square that. Which, you know, actually we can simplify that because we know what the square of 0.5 is. It's 0.25. So that basically says, if the cameras are really, really close to their destination of reaching where the combined view should be, then we just turn them off. So hopefully, we might have to tweak this value. It should be good. So now when they split, yep, and they recombine, and they split, and they recombine. I might find... Ooh, that was weird. Will that happen again? I can't tell. What if they're both moving? Will it struggle to get them to rejoin? It will. So that would be the one flaw, because it waits for them to move because of all the lerps. So what I will do is I will add the views combining timer and set it to 0 by default. And whenever the views are set to start combining, it's reset to 0. But whenever they're not combining, or whenever this is happening, what we do is we have views combining timer plus plus. So now, what we can do is we can have the arbitrary time limit, so that if it takes too long to combine, it will force it to combine. It's just an arbitrary unit. I'm going to put these both in some brackets. And I'm going to say, if views combining timer is larger than the arbitrary time limit, or either of those two cases occur, then it will force them to combine anyways. Now, the arbitrary time limit should force them to remerge if they take too long. They're not regaining their scripts. They're not regaining their scripts. Oh, because I've commented that out for some reason. But I can actually move that into here, I believe. Because they're now invisible again, they can just re-enable their scripts. Yeah? Will that be good? Yes. I'm going to increase the arbitrary time limit a bit, I think. Because it does have a little bit of a jump, so I'm going to increase the arbitrary time limit to about 45 frames. About 3/4 of a second. It is arbitrary, and you can just choose it based on how you feel. Ooh, that was weird. Oh, that's the whole thing where it can recombine, and then it waits for it to recombine before it merges them properly. Which was a side effect I'd already talked about, but it's there. You can fix that by, instead of waiting for views to combine, you can go, okay, well, if they're splitting apart again, then maybe we should resplit it. Which I suppose is the same as just copying this bit of code and then just popping it here instead. Which, you know, might be sensible. I'm gonna do that just to add some polish. We just grab that entire bracket. We just grab the entirety of that if. I'm going to leave that indented like that. Actually, I'm going to indent that once, and then indent that twice, just to show it's in the same place. That needs to be in an else. And then that gets to go over here. And then I think I've knocked a bracket off of there. Yep, there we go. Okay, so yeah, if they're diverging, then views combining basically just needs this bit. And that should automatically handle the divergence. Now, I'm sure this could be optimized a ton. Yeah, there we go. Got that working good. So yeah, now the views split, they combine, they're both animated, they've got limits so they don't ever end up in a frozen state. I think that's actually this done. Hopefully, this project will be downloadable, so you can look at it and play with it yourself. I'll hopefully have improved the commenting, so that it's easier to tell what does what. but you should be able to download this yourself. The controls are WASD for the red player, arrow keys for the blue player, but you should be able to look through it, try out the split screen stuff, hopefully make it yourself. And okay, thanks, love you, bye. Hope this helps.